Welcome. Let's take a look at another JTB, our third JTB, just the basics of first semester calculus quiz coming up shortly. And this got a little bit of a beast for second derivative. So let's go ahead and get started. First derivative, quotient rule, low, x squared plus 6d high times 5 minus high 5x d low 2x, all on the square of the thing below, x squared plus 6 squared. And I'm going to work this way into my graphing room. We're going to need some space here. So let's see, if we simplify the top, I get 5x squared plus 30 minus 10x squared on x squared plus 6 squared, or negative 5x squared plus 30 on x squared plus 6 squared, or I'm going to go right across here. Let's factor out that negative 5. Negative 5 times x squared minus 6 on x squared plus 6 quantity squared. So, most usable form perhaps for our derivative, I'm going to use that factored form. Negative 5 on x squared minus 6, all on quantity x squared plus 6 squared. So, when is this 0? When x squared minus 6 is 0, if x squared minus 6 is 0, x is plus or minus square root of 6. Square root of 6. Negative square root of 6, the slopes, y prime, first derivative, are 0. So let's find out. Well, clearly 0 is between these. If I put in 0, I get negative 5 times negative 630 over 6 squared. I get negative times negative, positives in here. If I put in a value such as 10, something out to the right, I get negative 5 times this factor would become positive. Negative times positive, positive. Oh, negative times positive, negative. Excuse me. And if I put in negative 10, as we can see, it's the same as putting in 10. Negatives. So our graph goes down, comes up, goes down. We have a minimum at negative square root of 6. We have a maximum at square root of 6. Our graph slope is negative until we get to negative square root of 6. So it's decreasing from negative infinity to negative square root of 6. In union with it, decreases again from square root of 6 to infinity. But it is increasing between the two. Negative square root of 6 to square root of 6. And that takes care of our first derivative. Second derivative, I'm going to use this. You can actually do it with this, but I'm going to use this one. So f double prime of x, just to get some new space here, I'm going to go equals negative 5x squared plus 30 on x squared plus 6 quantity squareds derivative. So just a repeat of there, and I'm starting with that derivative work right here. I think I'll draw a line here and just start working vertically here. So we've just got equals low x squared plus 6 squared d high times derivative of the top negative 10x, low d high, minus high negative 5x squared plus 30. D low chain rule. Treat the mama to something to the first. Leave the baby alone, x squared plus 6 times treat the baby 2x, all on x squared plus 6 quantity squared. And we've got a mess here. So here's what I notice. I've got a term. I've got a great big messy term here. But both of those terms, oh, by the way, this is x squared plus 6 squared squared. Both of those terms contain an x squared plus 6 factor. So I can factor out x squared plus 6 in the numerator and cancel one of these. So we would end up with still have an x squared plus 6 here times negative 10x minus still have, I think I'll put this 2 times 2x next, still have a negative 5x squared plus 30 here. But the x squared plus 6, I canceled this one with one of these. All on x squared plus 6 now to the third. And now I'm going to do some simplifying. I'm going to distribute that negative 10x in here. And I get negative 10x cubed minus 60x. I'm going to distribute this in here. I get plus 20x cubed minus 120x, all on x squared plus 6 quantity cubed. Let's see, combine my x cubes, 10x cubed, combine my x's, minus 180x, all on x squared plus 6 cubed. I think I'll factor a 10x out now, and I get an x squared minus 18. And that's pretty usable. So we have 10x, x squared minus 18, all on quantity x squared plus 6 cubed. When is that 0? Well, if x is 0, the numerator would be 0. I'm going to put it right between negative square root of 6 and 6. And if x squared equals 18, the numerator would be 0, so that's x equals plus or minus square root of 18 or plus or minus 3 square root of 2. 3 square root of 2 is definitely beyond square root of 6. So I'm going to put it out here. 3 square root of 2, negative 3 square root of 2, second derivative is 0. Let's pick some values. 1's between 0 and 3 square root of 2, so testing this zone. Putting in a 1, I'd get 10 times 1 positive, 1 minus 18 negative, positive times negative on positive, positive times negative, negative. Putting something beyond 3 square root of 2, clearly 10 is. If I put in 10, I get 100, and I get 100 minus 18. Both of those are positive. I expect this to be positive, but let's see. Put in negative 1, I get negative 10 times negative 17, positive. Expect this to be negative, but let's check. Put in negative 10, and I get negative 100 times positive. It would be 100 minus 18. So negative times positive, negative. Therefore, each of these is an inflection point. Cupping changes from cupping down to cupping up to cupping down to cupping up, and that's what an inflection point is. So our inflection points occur at 0 and at plus or minus 3 square root of 2. We are concave up from negative 3 square root of 2 until we get to 0, in union with 3 square root of 2 forevermore. And we are concave down from negative infinity until negative 3 square root of 2 in union with 0 to 3 square root of 2. And it's definitely come to my attention that graphing is a bit of a challenge for some of us on this. I'm going to rewrite my original function right here. F of x is 5x on x squared plus 6. So we can put all of this together. First three things I'm going to do, I'm going to figure out what f of 0 is if possible, and it's most definitely possible. F of 0 gives me 0 on 6, 0. 1 point that better be on your graph right there. I'm going to figure out what happens to the right, and I just want to get to the right of the fray. By the fray I mean to the right of these values. Once I'm over here, say at 10, I know the graph is going down. but cupping up. Let's see what f of 10 is. F of 10 is 50 on 106. And if I pick bigger values, the denominator is going to outpace the numerator. So this is trying to become little divided by big 0, but it's like positive 0, which means it's getting sucked into 0 from above. And let's take a look. That looks like it's going down. Looks like it's cupping up. Let's go f negative 10. We get negative 50 on 106. Wants to be negative 0. Wants to be coming in like this. Let's take a look. That's cupping down, and the slope is negative. I know it's going up to the left, but it's going down as it goes to the right. All right, let's see. We've got a maximum at square root of 6. I'll put it here. Got a maximum point somewhere up in here. The cupping changes over at 3 square root of 2, so cups up, cups down to right there. We've got a minimum at negative square root of 6, perhaps here. Its concavity changes at negative 3 square root of 2. We are cupping up between 0 and cupping, from 0 to negative 3 square root of 2, we're cupping up. Looks like this. That's the minimum. We're cupping up. And then when we get into here, we start cupping down. And there we have it. I think it's really tough to do without taking a look at what's happening at 0 and what's happening to the well to the right and well to the left. That end model behavior, very helpful for us. So hopefully that's helpful for you. Quiz is coming soon. Let me know if I can help you with anything.